Okay, and we're going to be assigning a specific configuration to a carbon atom in this lecture, and we're going to look and see how we do it. Specific configuration is just a way for us to communicate exactly how an atom has its groups arranged in space. And so this has nothing to do with chemical reactivity. It has nothing to do with how it polarizes light. This is just so that we can convey one to another a specific arrangement. So to do this, we assign a priority. And so I have another lecture in which we go through the Cahn-Ingold Prelog priorities. But right now, we're just going to assume we understand what the priorities are and look and see how we assign specific configuration. What we are going to do first is turn the molecule so that the lowest priority group is behind the carbon. I have these groups assigned priority 1, 2, 3, and 4, with 4 being the lowest priority. So when we go to assign specific configuration, we take the lowest priority group and we put it behind the carbon that we're analyzing. So I'm going to take this picture and I'm going to take the lowest priority group 4 and turn it around so it's back behind the carbon. When I do, priority group 3 is going to swing around to the left on the screen and priority group will swing around to the right. And what we're going to do is we're going to look and see if I look at the priority of the groups that we're looking at with the lowest priority group behind, which way is the order of priority going, clockwise or counterclockwise? If it goes clockwise, we assign it an R specific configuration. If it's going counterclockwise, we assign it an S specific configuration. So I've turned the molecule here so that the fourth priority, the lowest priority, is in the back. If I look at this, now I will see that the priority of the groups are going 1, 2, 3. 1 to 2 is going counterclockwise, clockwise, around like this. So R is clockwise, so we assign the configuration on this atom to be clockwise. If I just look at group 1 and 2, you can see going from 1 to 2 is in a clockwise direction. So we can say it's an R configuration. If it goes in the opposite direction, which it's an enantiomer, if you make a mirror image of this, you would see rotation would then be counterclockwise. So the enantiomer will have S, or counterclockwise, order of priority of the groups in the specific configuration. Now what you want to do is go to the next lecture where we actually look at the Cahn-Ingold Prelog, that's what CIP stands for, the Cahn-Ingold Prelog priority of groups so that you know how to prioritize.